Concentration is defined as the amount of solute that is dissolved in a given quantity of solvent. We can describe solutions as two different types. We have a dilute solution, meaning that it only has a small amount of solute, or we have a concentrated solution, meaning that it has a large amount of solute. There are lots of different units that we use to describe concentration, but the only one that we're going to be concerned with in this class is molarity. And so to calculate molarity, you take the moles of your solute divided by the liters of solution. Let's take a look at a couple of examples. So our first example says a solution is made by dissolving 0.90 grams of sodium chloride in 100 milliliters of water. What is the molarity? So our formula for molarity is moles of our solute, in this case NaCl, divided by liters of solution. So if we go back to our question, we notice that they did not give us either of those units. They gave us grams instead of moles and milliliters instead of liters. So we're going to have to convert those before we can plug into our formula. Let's start with our NaCl. So I have 0.90 grams of NaCl. In order to convert my grams into moles, I'm going to use the molar mass. So we have 1 times 22.99 plus 1 times 35.45, giving me a molar mass of 58.44 grams of NaCl, which is equal to 1 mole. My grams will cancel, and so now I have 0.015 moles of NaCl. Now let's convert our milliliters to liters. We know that we have 100 milliliters of solution. There are 1,000 milliliters in 1 liter, and so that gives me 0.1000 liters. Now that we have both moles and liters, we can plug into our formula. So my molarity is going to be 0.015 moles divided by the 0.1 liters, which is going to come out to be 0.15 molar. Let's take a look at another example. This one says how many grams of magnesium chloride are needed to make 100 milliliters of a 0.05 molar solution. Okay, anytime you see this big M, that stands for molarity, that's a big clue that you're going to use that molarity formula. So we'll start there. So this time, molarity is equal to moles of our solute, in this case MgCl2, divided by liters of solution. Okay, again, they did not give us liters, they gave us milliliters, but we did that conversion earlier, so we know that 100 milliliters is 0.1 liters. So plugging in, I have 0.05 molar, plug that in for my big M. We have 0.1 liters, and this time we're solving for moles. So when I solve that for X, I get 0.005 moles of magnesium chloride. But we're not quite done. They asked us for grams of magnesium chloride, not moles, so we're going to need to do some train tracks. So there is my 0.005 moles. We know that to go from moles to grams, we need the molar mass. And so 1 mole of magnesium chloride is going to have a molar mass of 95.21 grams. So my final answer, once it's rounded to 1 sig fig, is going to be 0.5 grams magnesium chloride. Another formula that we use quite often is called the dilution formula. And so we use this formula when we are taking a concentrated solution, that's what our ones are going to stand for, is concentrated, and diluting it down into a diluted formula or a diluted solution, that's what our twos are going to count as dilute. So let's take a look at an example of that. So how many milliliters of a 12 molar stock solution are needed to make 500 milliliters of 3.67 molar solution? Now, the best way to tell whether you need to use this dilution formula or the molarity formula is when you look at your question, you will either have 2 molarities, like we do here, or you would have 2 volumes. If you have either 2 molarities or 2 volumes, that's a clue to use the dilution formula as opposed to the regular molarity formula. So our formula for this one is M1V1 equals M2V2. Remember, our ones stand for a concentrated solution. Our twos are our dilute solution. So now let's plug in. So the first thing we need is the molarity of our concentrated solution. That's going to be the 12 molar. Remember, concentrated means it has a higher molarity. So we'll put our 12 molar on this side. V1, that's going to be our X because it's asking us how many milliliters of that 12 molar. Our M2 is the molarity of the dilute solution, which is going to be the 3.67, and the volume of that dilute solution is 500. Once we've plugged in, we'll just solve for X. And so this is telling us that we would need to measure out 153 milliliters of that concentrated solution to make this dilute solution.